a quick second part, that if you have a logarithm, do you have the skill to expand it as many logarithms? So now the other direction. You have one logarithm. Now write it with a bunch of logarithms, expanding it. So the first thing I notice is what's inside the logarithm. And what I see inside the logarithm is I see x times y cubed. Do you see the multiplying? And what that tells me, when you see multiplying, is I can expand it by doing what? And what we have to be careful about is that when we expand it and write the logarithm, that we write the base down twice there. 2 logarithms, the same base. So multiplying means, what am I going to do with the logarithm? Add it. Next, do you see an exponent inside the logarithm? That exponent can go outside, multiplying. And we need to have a skill to go from here to here. That you have the skill to see one logarithm and expand it completely. When you expand it completely, inside the logarithm will be a variable or a number. There won't be other things happening inside like that. Let's look at number 28. Do you see inside the logarithm we have m cubed divided by n to the 7th? I want to expand it so I have no exponents, no multiplying or dividing. Okay? Step 1. I see the dividing. When I see dividing, that means I can write it as 2 logarithms subtracting. So dividing inside the logarithm means you're going to subtract. Ln is a special logarithm that has a base of e. And we know that e is an irrational number in math, not a letter. Inside the logarithm, are there still exponents? So where does the exponent 3, what property will I use to write it differently? So that exponent can be written as a product in front of the logarithm. They're equal. You can take the exponent inside and write it as 3 times ln m. And what am I going to do with the 7? 7 times ln n. I know this is fully expanded because inside the logarithm is just a variable, no multiplying, no dividing, no exponent. Number 29. I hate talking over you. So I know that when I'm done, you'll have opportunity to practice for like an hour. Right? So let's focus here. 29. Do you see something inside the logarithm? Yes. What do you see? Well, I see a big square root sign. I see a cubed, and I see multiplying. So step 1 in this case is to write the square root as an exponent. So how do I do that? The square root is the same as what exponent? So I write it as an exponent. And the reason I write it as an exponent, because now I can apply the property. And the property is an exponent inside is equivalent to multiplying outside. Is this now fully expanded? No. How do I know? Because when it's fully expanded, you'd only have a variable or a number inside. I still see an exponent. I still see multiplying. So the 1/2 belongs to everything. So because it belongs to everything, and I'm going to expand, I'm going to use parentheses to show it belongs to everything. So when I'm multiplying, I'm going to write it as 2 logarithms adding. So instead of 1 logarithm, where you're multiplying inside, the property is you can write it as 2 logarithms adding. Now, there's a special name for this logarithm too. This is called a common logarithm, not because there's no base, but because the base is 10. Is it done already? No. What do I still need to do? Now, what property am I going to use here? When I see an exponent inside, I can write it in front, multiplying. Now look inside the logarithm. What's inside? Is it just a variable? No multiplying, no exponent, right? Now you know you fully expanded it. All right, number 30. Again, we're doing it together, and don't you worry, you'll have time to practice this. That's how I'll know if you know or not. So number 30, can you expand this logarithm? So step 1, do you see the exponent? I have to undo that first. So what property am I going to use to undo that exponent inside? Is that it's going to be a product multiplying in front of the logarithm. And I just break it down one property at a time. What's the next property I'm going to use to expand the logarithm? Do you see dividing inside the logarithm? So now what do I do? And remember, that 4 in front belongs to all of it. So I'm going to use parentheses because I'm going to eventually add or subtract as I go along, and that parentheses show it belongs to everything. So in this case, I'm going to subtract. And what am I going to subtract? Is c squared base 4 and log d base 4. Are we done expanding? So what's still left? So where does the exponent belong? As a product in front. Now look at the logarithm. Is it now fully expanded? So when I look inside the logarithm, I just see a variable. No multiplying, no exponents, no dividing, none of that. Right? We're ready. All right, try number 31. Now I'm going to give you a chance. I don't think you're awake or caring about this yet. So now 31, I feel I can trust you that you listen to me and you can try number 31. Yeah, thank you, Eduardo. Ew, really? A little bug? He was having breakfast too? Nice. Hey, we're not alone in the ecosystem. Did you know that? We pretend like we're alone in the ecosystem. Like bugs and rats and birds and stuff. They don't exist, right? Just us in some weird vacuum. Like we live in a space station or something. All right. You ready? We got this? All right. Hey, what's ln? How do I pronounce it? Ln. What's the base for ln? E in math is a number, right? Irrational, about 2.7. Yay. All right. How do I expand it? What should you do first? So I wonder if you did this first. Do you see the exponent 2 outside the parentheses? You have to start outside and work yourself inside. So on the very outside of what's inside is 2. So I first have to write down 2 ln 5p cubed q to the 4th. Did you do the first step correctly? Okay, try the next step. And do you know what happens when you get confident with properties? I'll tell you the good news of working with exponents and logarithms is that if you know what you're doing, the questions are quick. Like it takes a couple seconds and you got it, or you don't got it. But it doesn't take like a page or two or nothing. Like it's quick. And so what I notice is I see 5 times p cubed times q to the 4th. Do you see multiplying twice? Yes or no? So when I do this, I'm going to go ln 5 plus. Yes? Because it's 5 times. See, if you leave 5 in a variable, it can still be expanded, right? It's either going to be just a number or just a variable. And as you're multiplying, you know the property with the exponent? You can just do that in one step. So the next one would be ln 3 ln p. Do you see how I'm adding? And right away when I see an exponent, what do I do right away and not waste my time, right? How about the next one if I didn't want to waste my time? What would you put in front? And then ln q. How do I know that's fully expanded? Is when you look inside each logarithm, you either see a variable or a number, right? Then you know it's done. All right, number 32. The first step is, do you have a big exponent for everything? No. So the first thing we're going to do is undo the divide sign. How do I undo the divide sign? So we're going to subtract it into two logarithms. The skill of having to write it as an exponent is a big skill in calculus too. So when I see cube root of x, do you know the exponent that means the same as? So whenever you see a radical inside a logarithm, you have to write it as an exponent. Whenever you see a radical inside a logarithm, you have to write it as an exponent. And the exponent here is 1/3. Now the next one is a little bit different. See, x squared plus x, and this might get confusing after a while because adding and multiplying going back and forth. When you are adding inside a logarithm, there's no property. When you're adding inside a logarithm, no property. When you're subtracting inside a logarithm, no property. But if you're multiplying inside, then it leads to adding. If you're dividing inside, then it leads to subtracting. Get it? So right now, I can't do anything because adding, there's no property. But I can write it as a product. In other words, x squared plus x is factorable. And when you factor something, you're writing it as a product. Did you know that? That is factoring. Can you write it as a product rather than adding and subtracting? Thank you, Chris. I heard that. It's on the video. So, x squared plus x, is it factorable? Yes. How? An x. And when you factor an x, you get x and x plus 1. Now, factoring means you write it as a product. Now that it's a product, can you now expand it? Yes. So, let's go one step at a time. The exponent 1/3, where does it belong now? In front of the logarithm. The next logarithm is perfect. There's nothing I can do. Oh, right? What did I forget here? What did I do? That's just silliness. I think I just got excited about it, then wrote it again. Is that what I did? Well, Mr. Whiteout. Mr. Whiteout. There we go. All better. All good. So whiteout, right? Only God does math and pen, right? And me, apparently. So, how do I expand this? Log, what? X base 2. And because you're multiplying now, what are we going to put down? Add. And now what is it? Log x plus 1 base 2. Now when I look inside each logarithm, I see just x. I see just x. Now here I see x plus 1. Now we really understand this. That adding or subtracting inside a logarithm, there is no property. This is now prime. There's nothing I can do with that. It's not factorable. I can't write it as a product. It stays the way it looks. All right. One more piece of paper. Turn the page, and we're going to summarize what we just did. So this piece of paper is going to be the big one, right? Because you will forget eventually, now a year in college, and when you want to go back to remember your logarithms, do you remember the properties that you have it? So let's do this. So do you see this page right here? So here are some properties. Do you see a 1 inside the logarithm? No matter what the base is, the answer will always be, because When you evaluate a logarithm, you're finding the what? Exponent. So no matter the base, if the exponent is 0, the answer is always 1. So when you have a 1 inside the logarithm, what's the answer? Always 0. How about this one? When the base and what's inside, they match, what's the exponent all the time? And the answer is, no matter the base, if you raise it to the exponent 1, it stays the same. So when the base and what's inside match, the answer is always 1. Here's some examples. If I see a 1 inside the logarithm, the answer is 0, and I don't look at the base. It doesn't matter how ugly the base looked or how nice it looks. A 1 inside means the answer is 0. Here, what happens when they match? What's the answer? Done. Okay, the next property is the product property, which is a fancy way of saying multiplying. So what's the property? If you're multiplying, what do you do to expand it? And if you saw two logarithms adding, and they have the same base, you can write it as one logarithm multiplying. It goes in either direction. But the bases have to be the same to use that property going backwards. So, here's an example. What can I do to write this as one logarithm? Are the bases the same? So, because the bases are the same, I can write it as one logarithm. Because you're adding, what will you do to the two inside parts? Multiply it. So that means the same as 24x. Yes? How about the other direction? How can I expand this? Well, do you remember when I said that when you're adding or subtracting inside the logarithm, you're stuck. There's no property inside that allows you to do this. But what can we do to make a product inside? Factor. What can I do to factor this? What two numbers multiply to negative 2? Don't even draw a diamond. It's obvious two numbers that multiply to 2. 1 and 2. Which one needs to be negative? Which one's positive? The bigger number needs to be negative. The smaller number, positive. Now do you see a product? Now can you write it adding? So now it's ln x plus 1 plus ln x minus 2. And recognize that now this is all I can do. There's no more factoring. I can't write it as a product. When you see adding or subtracting, it's prime. I can't do any more with it. Okay, the next property, what is it? The quotient property is that if you're dividing inside, what can you do to write it as two logarithms? Subtract. And if you had two logarithms with the same base and subtracting, you could write it as one logarithm dividing, right? Either direction. So here's an example. How do I write that as one logarithm? First, are the bases the same? Yep, they both have a base of 10. So how do I write that as one logarithm? Is I divide the inside parts. So that would be what? 80 divided by 16. And that reduces down to just log 5. How about this one? Do you see dividing inside the logarithm? How can I expand that? Is log x base 2 subtract log 5 base 2. Are you getting more comfortable with the properties to go in either direction? Power property. The power property is if you have exponent inside, this is that rule when you have an exponent raised to another exponent, you multiply it, right? So that n, what the exponent is, can be a product in front of the logarithm. They're equivalent. Or the other way. If I have something multiplying in front, it can be written as an exponent inside. So look here. how can I write that without the 3 in front? Yes? What do you think 9 times 9 times 9 is? I definitely think it's 7, 20. Remember? Like, that's not too bad, right, in your head? What is it? There it is, right? Hey, how do I expand this? Do you see an exponent inside? That can be written in front of the logarithm. Notice 2 times x is not inside the logarithm, so we're not expanding that. It's just 2x in front. Inside the logarithm is just 3, and that's it. It's prime. The last property we use is so we can use our calculator. That we can change it to any base. And remember on R89, log isn't on her face, is it? So usually they say, hey, it's log A divided by, usually we say it's log A divided by log B, because most calculators have log on the cover, but ours doesn't. R89 doesn't have log, but on the face has what instead? Ln. So instead of using log, because it's longer to get to that button, we're just going to use ln, and they're equivalent. So you can change the base by taking what's inside and dividing over the base. Do you know if you're in stats, like your Nspire calculator, that you can just type in any logarithm directly? So, can you use your calculator and tell me how to evaluate that? So, whatever calculator you have, can you evaluate it? And if you don't have a calculator, you're just watching. So I want to evaluate that logarithm. So I'm going to use ln, ln, and it's ln 138. If you don't close the parentheses, it won't be happy with you. So you have to close the parentheses and then divide. And then again, ln, and this time it's 5. And if you just press enter, do you know what's going to happen? You're going to get a weird exact answer, right? So if I need to know the approximate answer, what do I use in my calculator? I press diamond and then answer, and then the approximate answer. Did you get that on the calculator? 3.061. So we went ln 138 divided by ln 5. On the Nspires, you just typed it in, right? We got to bring your calculators. And as we move on, right? We got them? All right. Hey, try the next one. Can you evaluate that one? Log 2 base 14. So again, I would go ln 2 divided by ln. In order matters. The base has to be in the denominator. Diamond enter. Did you get 0.263? If you round it. All right. There's our lesson on knowing, hey, what's a logarithm? Inverse of an exponential. We have a bunch of properties. We can evaluate it. We can write it as an exponential. And now you need to practice it. All right, GMath, over, out, done.